This is the vanishing rings and linking loops experiment. Bit of a mouthful. What you're going to need is some strips of paper. Now you can see in front of me here I've got these long strips. These are taken from a sheet of A3 paper and cut off the edge. But you can use smaller strips if you like, or maybe a bit of newspaper. It doesn't have to be white paper, any bit of paper will do. A strip like that would be handy. You're going to need some scissors. Now I've got two different sizes. I'm probably going to use these because I like using big scissors, but of course it might be easier and safer to use the small ones for you. And it will depend on how big the strip is. With big strips like this, I find it easier to use the big scissors. With little strips, thinner strips, I find the smaller ones easier. You decide. You're going to need some sticky tape. I'm using paper tape. Some people call it masking tape. You can use ordinary plastic tape, that's fine, doesn't matter. Just any sort of sticky tape. And you need a pen, because you're going to need to draw something in a minute. So I'm going to give you some instructions, a few things I want you to do, so watch carefully, because I need you to go away and have a go, and then we'll look at what you found out afterwards. The first thing is, you'll notice that if I take some tape here, and by the way, when you make these, I always recommend cutting your tape first. So I'm just going to put a bit there, on the edge of my table, and then I'll get a bit there. Because you're only going to have one spare hand in a minute to get that with, so I haven't got spare hands to reach for that. So here's the first thing I want you to do. First thing, turn it into a loop. Now at the moment I'm not going to stick it, but I want you to notice something. It has got two surfaces, one on the outside and one on the inside, okay? Two surfaces. What I want you to do is make a half twist just there like that. So I'll do it again. So turn it into a loop, just half a twist, a bit like turning the page in a book, okay? So hold it with one hand, I'm going to hold it there. I'm going to reach down, get a bit of my sticky tape, which I've cut already, now you can see why. And I'm going to stick that on firmly around there. Doesn't have to be perfect, but make sure the tape's long enough to go around both there and there. Okay, right the way around. Now what I want you to do is, using your pen or pencil, I want you to draw a line all the way around. I'm going to start mine off and see what happens. Because remember, originally when I first showed you, it had two surfaces, one on the inside and one on the outside. I want you to draw a line, start it off and come back to where you started and see what you notice. This is what I mean. I'm going to start it there. Okay, and I'm going to start drawing my line. And I'll have to move this around a bit and carry on drawing my line. It's a bit fiddly, so you're going to have to be a bit careful with this. And in fact, you could just do it like that. But keep drawing until you come all the way back to where you started from. Pick the loop up and see what you notice. Okay, so that's the first thing. I'll leave that one to the side, because now I'm going to show you the second thing I want you to do. I want you to get another loop, a piece of paper, make another loop, half a twist, remember. This time I want you to stick it together in exactly the same way. And this time what I want you to do is cut it all the way around the middle. Okay, really simple. The safest way to cut a hole in a piece of paper, in this experiment anyway, is to cut it there, okay, pinch it, make a little snip, and get your hole there that I've made, put your scissors through and cut all the way around the middle until you come back to where you started from, and snip into it and see what you make. How many loops will you have, do you think? Give it a go. One more. I've made one already in the same way. That was made in exactly the same way as that one. So I turned it into a loop and done half a turn, that was all. I'm not going to cut this one around the middle, I don't want you to either. What I want you to do, instead of cutting it around the middle, I want you to cut it nearer to one side, maybe about a third of the way across. Now I'm estimating this, I'm not measuring it, but about a third of the way, nearer to one side than the other side. And very carefully, I'm going to hold it like that, I'm going to stay cutting near to my thumb. Of course I don't want to cut my thumb, that won't be much fun. I'm going to keep cutting, and I want you to keep cutting until you come back to where you started from, making sure you stay near that edge all the time. Whatever you see happen, stay near the same edge all the time and come back to where you started. So all the way and snip right the way around again and see how many loops you make that time. Last thing I want you to do is get one more strip, turn it into a loop, make one half twist and another half twist. Now you remember on those it was just only a half twist. Overlap the surfaces a bit, get your last piece of sticky tape, put that on there, wrap it around, and rather like with this one where I cut it around the middle, I want you to do the same with this one. So remember how to do that. To get it going, you make a little snip of a pinch, open it up and start cutting. And see how many loops you get when you finish cutting there. Off you go. So, I asked you to do 4 different things actually. They're all related to each other. That's why I asked you to do them all. Hopefully you remembered. Here's the first one. Remember, I asked you to get your pen and start drawing a line, keeping on the same side all the time. Now I'm going to use my finger here to pretend that's my pen, but I've drawn mine already, as you can see, like I hope you did. And I did come back to where I started from, but then when I looked, I noticed, as I'm hoping you did, that there was a line on every surface. But I never stopped drawing on the same side. I didn't turn it over and start drawing on the other side. So that means there can only be one surface, one long line on one long surface. So you've just proved by using a pen there's only one surface. Even though on the original one, when we didn't have the twist in it, it had 2, one on the inside and one on the outside. This has only got 1. Interesting, we'll come back to that later as to how useful that can be. This one, I asked you to cut that around the middle. Now as you were cutting, some of you I'm sure were probably thinking, oh, it'll make 2 loops when I'm finished. Well, I hope you discovered something rather more interesting than that. You come back to where you started, cut into it, and yes, it does appear to be 2 loops, doesn't it? But look what happens when you just pull it open. It gets bigger. So cutting this round the middle doesn't turn into 2, it gets bigger. Rather weird. Do that there. What about this one? Now, do you remember this one was the one where I said to you cut it so that you are about 1/3 in from one edge? Okay, I said stay nearer to one edge than the other. Now this is, I think this is even more peculiar than the other one. So you keep cutting, I'm going to carry on cutting. I'm hoping you've all done this one. This is a bit fiddly, but notice I'm staying near the same edge where my thumb is all the time. I'm not moving away from it, trying to stay roughly the same distance. Doesn't have to be exact, of course. And you will come back to where you started. Coming up, there it is. One long cut, just one very long cut. There it is. What's happened this time? Rather more weird, I would say. This time you have 2 loops joined together and they're not even the same size anymore. In fact, the one I'm holding, is twice the size as the other one, the one that's hanging down there. 2 loops joined together from one cut. Weird? Last one. That's the one where I did 2 half turns. Remember, I turned it over once, turned it over a second time. And initially, as you started cutting it, it probably reminded you of the first one where you cut it round the middle. But remember, the first one only had 1 half turn in it. This has got 2. So let's have a go. So we go around all the way. You will come back to where you started. This is a little bit more fiddly. Take your time, of course, don't rush. Take your time. You don't want to snip yourself accidentally. And you'll come back to where you started. There it is. Now it looks a bit like the other one did, but when you open it out, it's now joined into 2 loops joined together. This time they're the same size. Weird. So, what is going on with this one? Weird. Now, first thing I should tell you is this is actually a mathematical trick as well. It's from a rather peculiar type of math called topology. Now, one of the things topology is used for is studying the properties of three-dimensional shapes and three-dimensional surfaces. So that's one of the things we use topology for. We've made a rather famous topological shape called a Mobius loop. That's what it's actually called. Sometimes it's called a Mobius strip. But Mobius loop or Mobius strip's up to you. Invented by Mr. Mobius. Or I should say invented, probably discovered by would be a better description. Now, one of the weird things you've discovered is that a Mobius loop only has one surface. Now, where this can be useful to scientists, and one of the reasons I'm showing you now, is because only having one surface means if we were to measure that surface, although we haven't done it now, it's about twice as long as the two separate surfaces were before. If we measured each one of those surfaces on an ordinary loop, one on the inside and one on the outside, the length of this surface is about the same as those two added together. You've got to allow for the overlap, but it's about the same. Now, if we use this in an engine, where some engines have little wheels they've got to join together with a band, sometimes we use an ordinary band that's got one surface on the inside and one on the outside, and that's very commonly used. But now and again we do actually use Mobius bands to link them for two reasons. One is, it can be that it takes a lot longer for the belt to wear out. Because think about it, it's the surface that's rubbing on the wheels, or the little gears, whatever it's turning. So with a Mobius band like this, it takes longer to wear out because it's actually got a much longer surface than if it had been an ordinary band. So it takes longer to wear out. A more interesting use of it is look at the way the band hangs down. If I put my fingers in like this, my thumb is pointing forward, my finger is pointing to the side, so they're at what we say right angles to each other at 90 degrees. So in other words, the Mobius band has got a 90-degree bent hang from one end to the other. And this is often used to link things like pulley wheels, which are at right angles. So I can give you an example I remember seeing a vacuum cleaner, an upright vacuum cleaner that you push along with a broom, a motorised broom I suppose, and the spindle with the brush that was going that way, and the little pin that was coming out of the motor was pointing that way, and they linked them together with a Mobius band. I was once working with a teacher who was brought up on a farm, and she told me she remembers seeing these linking together the motor and the spinning bit on a combine harvester machine. Now, I haven't seen that myself, but she told me, and someone else said that was true as well. So there's two examples, and there probably are others. So that's the first interesting thing. All I can really say about the others is that what happened is a product of the shape we made. It's a rather strange shape, and by putting that twist into it as I did, it's changed its properties so that even though it starts off as one and it looks like it's going to become two, it actually stays as one, but just twice the size. And you saw a couple of other things that happened as well. So it's going to be easier for you to understand this, particularly the first one where we just cut that around the middle and it got bigger, if you do it a few times yourself, and then you'll get an understanding in your imagination of what's going on. Quite often people do it a few times and they say, oh, I see, I get it. But it's actually quite hard to find words that describe why it does it. And I'm no better at that than you are. So I suggest you have a go and do it a few times, and then you'll get the light bulb go on. Aha, I understand. Okay, so what about some things you can change? I think you've already got a few good ideas straight away. How about the first one we did, remember, we just cut it around the middle, it got bigger. How about cutting it a second time? Will it get bigger again, do you think? Will it keep getting bigger if you keep cutting it around the middle? See what happens. Same with this one. Do you remember the second one I asked you to do the cutting on? That's the one that ended up, as this one did, with a big loop joined to a small loop. What about if you cut, say, the little loop around the middle? What do you think will happen to the whole thing? What about if you cut the big one round the middle? What do you think will happen to the whole thing? Same with this one. This was the third one you did the cutting on, remember? We ended up with two loops joined together. I wonder what would happen if we cut that loop round the middle. What would it do to the whole thing? What about that loop to the whole thing? Now, do you remember on this one, when I made it, instead of doing just one half turn, I did two half turns, remember? What about if you did three half turns and tried to repeat all these? Cut one round the middle, one near the edge. What do you think would happen? 4 half turns? So in other words, you can change the turns as well. I'm sure you can think of some other things to do.